Okay, so there are several exponential rules that we are going to use to evaluate with numbers and variables combined. The first one is when I am multiplying the same base, x to the n power times the x to the m. We keep that base, we keep the x, and we add the exponent, so n plus m. So if I had, for example, x to the third times x to the fourth, I would keep the x, and then I would just add the exponents. 3 plus 4 is 7, and that's how that would look. Number 2 is when you have a fraction, or you're dividing with the same base, you keep the base and you subtract top exponent minus bottom. However, when we get to these more involved problems, I think about it a little bit differently because we'll get the negative exponents and all that, so I'll talk to you about that when we get to some examples. But again, if I had x to the fifth divided by x squared, I would keep the x and I would subtract those exponents, and that would give me x to the third. Number 3 is a power to a power. So if I have x, some number raised to a power, and then it is raised to another power on the outside, we keep the base and we multiply those exponents. So if, for example, x squared raised to the third power would become x to the 2 times 3, which is x to the 6th. And number 4 is very similar to number 3, except for this time I have a product of things inside of my parentheses, and then I have an exponent on the outside. And what happens here is that exponent is going to be multiplied by the exponents for each piece inside. For example, this x has a 1 as an exponent, maybe. Here we go again. And so does the y. And so what I do is I multiply those two exponents, and that gives me x to the m times y to the m. So, for example, here, if I had xy and I squared it, then that would become x squared, y squared. We would give that exponent to both of those. If I have a fraction inside of a parenthesis, bless you, and an exponent on the outside, that exponent is going to go to both the numerator and to the denominator. So if I had x over y and that was raised to the third power, again, we're multiplying exponents, but it goes to both the numerator and to the denominator. So that would become x to the third over y to the third. And then probably the one that we have the most difficulties with is the negative exponent. I have people all the time trying to change the sign of the base. Okay, that doesn't work. The negative exponent changes your location in your fraction. If it is a whole number, to make that exponent positive, you would move it to the denominator. If you have a negative exponent in the denominator, it would move it to the numerator. It doesn't change anything else other than the sign of the exponent by changing its location. So if I had x to the negative 2, that would become 1 over x squared. Does that make a little bit of sense? All right. So we're going to start with just numbers first. Your calculators can do a lot of the numbers and exponents for you. If you want to get one, I can show you how to do that. Otherwise, you just have to figure out what everything is. We evaluate all numerical bases with exponents unless it is like a really large number. Like if I did, I don't know, 2 to the 30th power, I would not expect you to multiply 2 by itself 30 times, okay? But any reasonable number, we're going to actually evaluate. Is everybody ready? So we do not leave any negative exponents in our answers. That is not completely simplified. And again, if you have any numerical base raised to a power, we are going to actually figure out what that is. The first few are very simple. We've got 4 to the third power. That means I'm going to go 4 times 4 times 4. You can do that in your calculator, or you can just multiply. Either way, 4 to the third power, again, means 4 times 4 times 4, which gives me 64. So go ahead and try 2 and 3. And the calculators, depending on what kind of calculator you use. If you're using my calculators, the exponent key looks like that. So you would, like, for example, you would hit 4, you would hit the exponent key, and then you would hit 3, and it would do it for you. if you have some other people have a calculator that has an X with a Y on it, like as an exponent, that's your exponent key there. It just really depends on your calculator. If you're not sure, I can show you. No. So what is 8 to the first power? 8. Okay. And 5 to the fourth means 5 times 5 times 5 times 5, which gives me 625. So far, so good? Now, number 4 is a fraction with an exponent on the outside of the parentheses. So remember the rule that says if you have a fraction inside of a parenthesis, the exponent on the outside is going to go to the numerator and to the denominator. What is the exponent on the 1 and the 2 right now? A 1. Sorry. And because it's on the outside, we multiply, maybe. So that becomes 1 to the 5th. And then we do the same thing at the bottom. And 2 to the 5th. And then we just want to simplify that. What is 1 to any power? 1. Okay, and 2 to the 5th. 2 times 2 times 2 times 2 times 2 is 32. And then, as always with fractions, if you can simplify, simplify. However, 1 over 32 does not simplify. We kind of okay with those first 4? Right. Now, let's focus on 5 and 6 for right now, because they are very similar questions, but completely different in the way that we evaluate them. What's the difference in the two? One has parentheses, one does not. Okay. So here's the thing we need to think about is when we're talking about exponents, exponents are attached to whatever is directly to their left. Okay. In this case, number 5, the exponent is attached. Sorry, this thing has not been working and it's driving me crazy. The exponent is attached to the parenthesis because that is what is directly to its left. In number 6, it's attached to the 3. We always think about a negative number being just that, a negative number. But essentially, isn't negative 3 technically, couldn't I break that down to do negative 1 times 3? Isn't that the same thing? Okay. All of that is in the parenthesis here, which means all of that is going to get raised to the 4th power, which means I am going to take and I'm going to multiply negative 3 by itself 4 times. So negative 3 times negative 3 times negative 3 times negative 3 is going to be a positive 81. If you're entering that into the calculator, it is very important that you put the parentheses when the parentheses are in the problem. If you don't put the parentheses in the calculator, it's going to give you a different answer. With 6, however, this is technically negative 1 times 3 to the 4th power. Do you see how that 4 is only attached to the 3 and not to the negative? So this would be negative 1 times 3 times 3 times 3 times 3, which would not give me a positive 81. It would give me a negative. So here's what I like to say. If you have a negative sign inside of the parentheses, that negative is going to travel with the number as you multiply it. Negative 3 times negative 3 times negative 3 times negative 3. If you have a negative that is not inside of a parenthesis and the number it's next to has an exponent, that exponent is just applied to the number and you stick the negative in the answer. Does everybody see the difference between the two? The parentheses carries it with it. If it doesn't have parentheses, it does not get carried. We good with that? Okay. All right, number 7, I want you to do that one. I need you to evaluate negative 2 to the 3rd, and then evaluate 5 squared, and then you would multiply the results. Again, if you're using your calculator, make sure you put parentheses when they are written in the problem. Otherwise, it will give you a different answer. Not all the time, but sometimes. What is negative 2 to the third power? Negative 2 times negative 2 times negative 2. Negative 8. Okay. And what is 5 squared? 25. And then we multiply those and we get negative 200. Is everybody kind of okay with the numerical simplifying? Got a little bit more. We're going to add in some negative exponents now. Take a minute and write down the first couple. We'll work those out. So number 8 says 2 to the negative 4 power. And again, we cannot ever leave negative exponents in our answers. That's not completely simplified. And to make the exponent change from a negative to a positive, we have to change the location of the base being 2. Where is that 2 right now? Is it in the numerator or in the denominator? It's in the numerator, right? Because isn't that technically over 1? Okay. So to make that 4 turn positive, we're going to take that entire thing, that 2 to the 4th power, and we're going to put it in the bottom of the fraction. What would I have to put in the top if there's nothing else up there? A 1. And then I would just ask you to simplify that and tell me what is 2 to the 4th power. 16. You can also do that in your calculator. If you have my calculator, there's something I need to teach you how to do. So what I want you to do is hit 2. Hit your exponent. If you don't have my calculator, I'll have to look at yours and see what your answer looks like. And then you're going to raise it to the negative 4 power. So this is the buttons I'm hitting. I'm hitting 2, the caret key, and then the negative 4 power. And I get in my calculator 0.0625, right? So what you can do to change that to a fraction is you hit your second sign, hit the blue button, and then the second row, second column, it says PRB. Right above that, it has a F to D button. Do you see the F to D on the calculator? That means fraction to decimal. So if you hit the second and that PRB and then hit equals, it changes it to a fraction for you. It's got 1 over 16. Some of your calculators may give you the answer as a fraction. Yeah.
Do you want it as a fraction?
Yes. No, we want them as, because we're going to get into some complicated problems that you'll have more stuff going on than just the number. So yes, I want to leave everything as a fraction. Is everybody okay with that? All right, try number 9 then. Tyler, does your calculator leave it as a fraction or decimal?
I can see.
So 2, there's your exponent. But if I'm calculating, it's not mine. I
don't know how you do that.
All right, number 9 says 1 over 3 to the negative 3, but I cannot leave negative exponents. Where is my base 3 right now, in the top or the bottom? In the bottom. So to make that exponent turn positive, it's going to move to the top, and it just becomes 3 to the 3rd. Technically over 1, but do we have to write that over 1? No. And what is 3 to the 3rd power? 27. Everybody okay with that so far? All right, we're going to take a look at number 10. I have 4 to the negative 3rd power times 1 over 2 to the negative 4. What I would recommend is let's rewrite each part of this question without our negative exponents. So let's start with the 4 to the negative 3. Where does that go to make that 3 positive? The bottom. So it becomes 1 over 4 to the 3rd, which is going to be 1 over 64. And then for the second part of that, to make that exponent on the 2 positive, where does it move? To the top. So it becomes 2 to the 4th. And then 2 to the 4th power is just 16. And again, depending on how comfortable you are with your fractions, you can also let your calculator do the work for you. If you don't know how to enter a fraction in the calculator, I can show you that. But when we multiply fractions, that 16 is over 1, we literally go straight across. Top times top, bottom times bottom. And then, as always, with fractions, if we can simplify, we simplify. Your calculator can also do that for you. If you're not sure how to do that, I can show you that as well. What can 16 and 64 both divide by? 16, so that becomes 1 over 4. Is everybody okay with that one? All right, try 11. That is negative 2 to the third power times 1 over negative 6 to the negative 2 power. If you're doing negative 2 to the third power in the calculator, you do not put parentheses because it does not have parentheses with it. But if I do negative 2 to the third power, what does that give me? Negative 8. And then for the second part, to make the exponent turn positive, it's going to move to the top. So that becomes negative 6 to the positive 2, which is going to be how much? 36, okay. Negative 6 times negative 6 is 36. That one would require parentheses in the calculator because it has parentheses around the negative 6. And then I can multiply negative 8 times 36, and that's going to give me negative 288. Any questions so far? Here's one more rule for exponents that we did not include in the first 6. And that is anything to the 0 power is 1 with the exception of 0. That's why it says x cannot equal 0. If you did 0 to the 0 power in your calculator, it would tell you there's an error because that's undefined. You can't do that. But anything else raised to the 0 power is going to be 1. And again, you can also put these in the calculator and let the calculator do the work for you. It just will not be able to do the work once we get to the variables. But if it's all numbers, you can use the calculator for sure. So what is 5 to the 0 power? 1. What is 1 over 2 to the 0 power? 1. And then I have negative 3 inside of the parentheses raised to the 0 power. What would that be? 1. Let me ask you this. What if I wrote it like this? If I wrote it without the parenthesis, what would that one be? That would be a negative 1, yeah, because the negative does not go with it. So be careful with those. But on 14, because the exponent is outside of the parentheses and the negative is inside, the whole thing is raised to the 0 power, which makes it 1. We good? All right, let's throw some variables in here now. Take a minute and write down the first couple. We'll work through them in just a second. So with 15, we have x to the 5th times x to the 7th. The rule says if I am multiplying the same base, is my base the same? Yes, okay. I keep that base and I add the exponents. So what is 5 plus 7? 12. Now, number 16, we can do a couple of different ways, and I'm going to show you both. It is very similar to 15 in that we are multiplying the same base. I have x to the third times x to the negative fifth. So the rule says that we keep the base and we add the exponents. What is 3 plus negative 5? Negative 2, okay. And then we cannot leave negative exponents. So what does x to the negative 2 become? 1 over x squared, yeah. That's one way you can do it. Now I'm going to erase this and show you a different way, and it depends on how you see and which one you're more comfortable with as to how you can do it. Okay, so let me erase. We know what the answer is supposed to be. But another way we can do this is we can keep that x to the third, and we can rewrite x to the negative fifth as 1 over x to the fifth. Sorry, that's not writing properly. And then we would multiply straight across. So x to the third over x to the fifth. And then this is when I was telling you about I don't always subtract my x. You do, but not really, because we end up getting another negative exponent. What I look at is this. I have how many x's at the top? 3. How many at the bottom? 5. So what I ask myself is, where do I have more x's? Do I have more x's at the top or at the bottom? At the bottom. So what I can do is I can simplify that. All of my extra x's will stay at the bottom. How many extra do I have? 2. And then if there's nothing left at the top, what do we put? A 1. Okay, put a 1 there, maybe. Which is the same answer I got before. Or we could go from this point, and we could say, all right, we would do x to the 3 minus 5, which would give me x to the negative 2, which I then would simplify. So there's a couple of different ways around it. It just depends on which way makes more sense to you. Good? Okay. All right, number 17, go ahead and try that one. I have a power to a power. So if you're not sure, look back at your rules. This was like number 3, I believe. When you have an exponent raised to another exponent. Were you done with that part? Okay, here. There. What does the rule say I do with those? Multiply. Okay. So we would take and we would multiply those two, and that would give me x to the 12. All right, I want to do 18 with you, then I'm going to let you try 19, and then we'll do 20 together, and then we have one more after that. So number 18 is like the product rule. That's number 4, I believe, that we listed. Everything inside the parenthesis is going to be raised to what power? What's the power on the outside? The 3. Okay, so what that means is, and a lot of people make a mistake on this one, they forget the 2. What's the exponent on that 2 right now? It's a 1, right? So the rule says power to a power. What do we do with those exponents? Multiply. So that becomes 2 to the third. And then it becomes x to the 6th. And then the only other thing I would do is simplify. And what I mean by that is I would write, what is 2 to the third power? 8. So I would rewrite that as 8x to the 6th. Try 19. You said, same concept as 19, except for it's just got a little bit more to it. Yes, this one is. Same concept as 18 on it. What's the exponent on the 2 inside the parenthesis? 1. The x has a squared next to it. What about the y? What is its exponent? 1 as well. Try to put those in there if my pen will work. Come on. I'm trying to write it, y'all. It's not working. So I have 2x squared y z to the third raised to the third. So again, the 2 and the y also have a 1. So when I give this exponent to every single piece of this product, I multiply the exponent, so that becomes 2 to the third. And then it becomes x to the 6th. And it becomes y to the third. And then it becomes z to the 9th. And then the only thing I can do, I don't have a fraction to simplify, but I can evaluate what is 2 to the third. 8. And so I would write it as 8, x to the 6th, y to the third, z to the 9th. Is 20 very similar? What's a little bit different? What do I have in this one that I did before? Negative exponents. So what we want to do is we want to do the same thing that we just did with number 19. Is I want to first of all give this exponent to every piece of my product inside. So that becomes 3 to the negative third. It becomes x to the negative 6. And that z is going to now turn into z to the what? Positive 12. Because negative 3 times negative 4 is a positive 12. Are we allowed to leave negative exponents? No. So what I need to do is every piece of this that has a negative exponent attached to it needs to move. They're all in the top right now, so that means they're going to have to go to the bottom. Does the 3 move? Yes. So that becomes 3 to the positive 3. By moving it, it makes the exponent positive. Does the x need to move? Yes. So that becomes x to the 6. Does the z need to move? No. So it's going to stay at the top. I'm going to put 3 to the third as 27. And then I just need to double check. Is there anything that I have the same at the top and the bottom that I can simplify? No. So we leave it just like that. Take a minute, write down 21. Let's see if I can get this to I have 3x to the third y squared in parentheses. What's on the outside of that parentheses? A 2, an exponent, right? And then I am multiplying that by 4xy to the third. So let me ask you this. What comes first in your order of operations? Multiplication or exponents? Exponents, right? So in this problem, before I can multiply those two parts, I have to get rid of the exponent that is on the outside of the parentheses. So, it's still not going to write that. what I want you to do first is give the exponent, that 2 on the outside, to all parts inside. Just like we did before. That becomes 3 squared. That becomes x to the 6th. That becomes y to the 4th. And then I'm just going to write this. What is 3 squared? 9. Does this second parenthesis have an exponent on the outside of it? No, so I'm just going to bring that down. Okay, parentheses next to each other mean to multiply. So what I need to do now is I need to multiply 9x to the 6th, y to the 4th, by 4x, y to the 3rd. And we're just multiplying. We're not distributing anything, we're just multiplying the like parts. What is 9 times 4? Okay. If I do x to the 6th times x to the 1st, that's going to give me x to the 7th, because we add, yep. And then y to the 4th times y to the 3rd is going to give me y to the 7th. Any negative exponents? No. No fraction, nothing to simplify, so that is exactly how we leave our answer. Anybody have any questions? Your homework is page 24 and 25. You're doing 1 through 31 odd. Again, all of this is going to be